pleasure here to introduce Rachel Lester. She's been working with me for 2 years now. Last year she was presenting some work where she worked with some oil dispersants with frog embryos. And this year we started working with Dr. Teratogen in chemistry, looking at the effects of phthalates. She was interested in, Dr. Teratogen was interested in developing some phthalates, and so we were looking at doing the frog work to see if it would be a good model for this phthalate work. Rachel said she'd be interested in working with that, so she continued on with that project. So she's going to tell us what we found.
Hi, like Dr. Rimmon said, I'm Rachel Lester, and I did my work on the effects of diethyl phthalate, DEP, on Xenopus Laevis frog embryos. Okay, so a little bit about diethyl phthalate. It's a plasticizer. It's additives for plastics. It's usually used in like flexibility and durability for plastic. And at room temperature, it's a clear liquid. It's slightly denser than water, so in our experiment, you have to mix it and make sure it goes into solution before we can test on it. It's just a bioagent used in cosmetics, fragrances, things like that. And we're just interested in like developing non-toxic plasticizers for like future uses and stuff like that. So the Xenopus laevis, that is a model organism that we use. It's a South African clawed frog. It's aquatic, so it's easy to obtain. The females are slightly larger than the males, and you see the female and the big one on the bottom. We use albino males just to distinct the sexes easily. They reach sexual maturity usually after 1 to 2 years. And after that, we obtain eggs. You see in the bottom of the grate there, there's little black things, those are eggs. And they're usually about 1 millimeter in size, so they're easily manipulable. And phases of development are easy to establish, so that also helps us with our testing. So what is FETAX? It's just frog embryo teratogenesis assay Xenopus. And it's just a 96-hour test that basically can tell us if a certain substance is a teratogen or not. These 4 stages here are just, that's a blastula stage after 20, when the egg first comes out, then 24 and 48, 72 grams, the free living tadpole at the end of the test. So there's easily to determine like the stages of development and make sure everything is going properly. We see these different stages. So the objectives in our experiment was to determine if the FETAX assay can use to determine toxicity and teratogenicity of the phthalate compounds. Like I said earlier, to develop for developing plasticizers to determine if they can be toxic. And my null hypothesis for this experiment was to determine if this particular plasticizer was not a teratogen. The FETAX will help us determine the levels in the DEP that will affect growth and development, survival overall. So my materials and methods that we went through. First, breeding process. We gather the 2 frogs that are sexually mature after a year or 2. We inject them with HCG, which is human chorionic gonadotropin. It's just the sexual hormone found in pregnant women that lets us know that they're pregnant, and that helps induce breeding. And once we inject them, we put them in a false binding green enclosure, as you see in this picture, and we leave them overnight with FETAX and running air, and hopefully frogs' eggs are produced the next day. Okay, so after we get the eggs, we take them out of the grate, we put them in a flask, and use 2% L-cystiene. And this just helps us remove the jelly coat. The jelly coat needs to be removed so we can help manipulate them better, because if it's on it, they'll stick, and we can't get to them like that. And we just do a 2-stage, 3-stage sorting to make sure the best eggs are used possible in the experiment, so it's like an even starting point for all the eggs. So the setup for DEP, this dish right here just shows how the eggs look during the experiment. We have 20 eggs in each dish, and then we have 2 sets of controls, which is 4 total, so 4 controls of the dishes, And then we have 6 different concentrations with 2 replicates. So overall, we use about 320 eggs for per experiment. 3 experiments are done, plus a rangefinder at the beginning. Okay, so during the test, like I said, it's a 96-hour test. So at 24, 48, and 72 hours, we check for DEP, and we record the pH just to make sure that's not a factor. And then we remove the dead embryos, and then we change out solutions every day to the last day. The last day, we check for mortality, malformations, and length measurements. And we do all that using Barker's tests and vertebrate testing to get our statistics. And this is just a picture of what a normal tadpole looks like. You see like just round, regular round face, pretty much straight back, about 1 centimeter in diameter. Length. And then the results. So this is our concentration response graph, showing us mortality and malformations. This graph can show us that there's, with the lines being close together, that shows us that it's technically not a teratogen, so that the more malformations we see, the more mortality we see. And the red asterisks you see at the top, it just shows us that those specific concentrations are statistically different than the controls here. This is our growth graph. This also shows us the length measurements compared to controls, compared to different concentrations. Again, the red asterisks just show us that those specific concentrations are statistically different, and that those long bars coming out are just the standard error bars. So the statistics we got, the LC50, which is lethal concentration, EC50, effective concentration, NTI, teratogen index. These are based off the 3 tests, and the parentheses underneath are just the 95% confidence levels. We get our TI by dividing our LC50 and EC50, and teratogen by both the same thing over 1.5. So as you can see, all of our tests came back less than 1.5. And as I showed you earlier, the normal embryo at the end of the stage is like straight and round face. And these are some of the pictures that we got from different concentrations. At 25 ppm, which is parts per million, basically it's just like 1 penny in a million pennies, to break that down. Curvature of the spine. At 50, we saw edema, just swelling of the gut here. It's like really severe. Also, this is one that has both a really curved spine and edema. The gut looks not coiled, which it should be. So those are just the severe abnormalities we saw at these different concentrations. And this is mostly all of them, so that was really bad. And in conclusion, basically because our TI was less than 1.5, it is technically low teratogenic risk. But the severe abnormalities I showed earlier indicate that some type of chemical investigation, I think, should be done, because it is causing some type of developmental effects, even though it's technically not teratogen. And so I'd just like to acknowledge Dr. Reverend, my mentor, JSU Biology Department and Chemistry Department, and the faculty